Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to the last lecture of week 5 for this ongoing course on understanding and reducing greenhouse gas emissions, where we are looking at emission reduction through building design and construction, especially focusing on scope 1 and 2 emissions. In this week, we have seen examples of different companies, different sectors, and we have tried to understand their scopes of emissions, scope 1, 2, 3 of emissions, and we have also seen how buildings affect different scopes of emissions. For certain businesses, for certain sectors and companies, businesses play a significant role, very important. For example, universities. While for certain others, they do not play as significant a role, but overall if we see, buildings contribute significantly to the overall greenhouse gas emissions of the world. And so, what we are emphasizing here is to look at the building design and construction right in the beginning, which will affect the greenhouse gas emissions of the world at large and for individual companies also. So, in today's lecture, we are going to see the emissions which are coming from real estate companies. So, these real estate companies are not building for themselves, they are constructing, they are making buildings for different other companies, for different users. So, they could be commercial users, they could be industrial users, they could be individual homeowners or office owners. So, it is for a user that building is being constructed as a product, and in this process a lot of emissions are released, and this is what we are going to see. Where are those scope 1, 2 and 3 emissions, and what can we do? Unlike all the previous examples, the 4 examples that we have seen in this week, for real estate companies, buildings are their products. So, unlike airports or universities or IT sector companies, where buildings are the assets that they own or they use, so it is operational part of it. For real estate companies, the buildings are products. So, there is operational energy that is going in, but there is a lot of scope 3 emissions which are going to accrue, because buildings are going to be handed over to users as products. Let us see the scope 1, 2 and 3 emissions for these real estate companies. Quickly looking at the previous lecture, we looked at the tech companies, the IT sector companies, and we understood their scope 1, 2 and 3 emissions, and we also looked at the case study of Microsoft, where it has clearly identified the role of making energy efficient buildings in reducing GHG emissions. Today we are going to look at the carbon emissions for construction sector at large, and then we will look at scope 1, 2 and 3 for real estate companies, and then we will look at the case study for Mahindra Life Spaces. If we look at the overall global carbon emissions by sector, we will see that building operations, building materials, the production of them and other manufacturing for building materials, that takes up around 50% of the total GHG emissions of the world. So, we can clearly see that it is extremely important to focus on building design, because it is going to affect the operations, the GHG emissions due to building operations, and almost the remaining quarter is coming from manufacturing of these materials and the emissions due to these materials. So, together we are looking at a significant portion of overall GHG emissions when we say we have to look at building design and construction and reduce the emissions there. If we are looking at the construction industry itself, just the building industry and the entire value chain, we are looking at largely 2 components. One is the operational carbon, the emissions which are the emissions which are emitted during the operational phase of the building. Now, that is largely coming, this operational carbon is largely coming from the consumption of electricity or other types of fuels. This is the energy or the fuel that is consumed when the building is in operation, and if we look at the data, we will see that a large amount of this energy is actually going in conditioning the spaces for creating thermal comfort indoors in the buildings. That is where large amount of operational emissions are happening. When I say comfort, I do not only imply thermal comfort, we are talking about visual comfort. So, we need adequate amount of light inside the building to perform the activity for which the building is being designed for. So, we are looking at overall comfort, where it is thermal comfort, it is visual comfort, it is acoustic comfort. So, a lot of energy is going into buildings during the operational phase to enable, to provide for this comfort. Plus, we have a lot of appliances and equipments that are inside the buildings depending upon the usage. For example, we have a residential building. So, the residential appliances will be there. If we are talking about office buildings, maybe we have a lot of computers. If it is a university building, we may be having a lot of computers, printers, that kind of equipments and appliances. If it is a data center, we might be having a lot of servers and other things. So, depending upon the usage, we may also be having the process load. But if we look at the overall number, we will see that we have a large amount of this operational carbon, this operational energy, which is due to provision of comfort inside the building. So, that is the prime purpose of buildings. We make buildings to protect ourselves from the extreme climate, the environment outside. So, when it is extreme heat outside, we still have comfortable indoors. When it is extreme cold outside, we still have comfortable indoors. When it is raining heavily, we can stay safe. So, this is the prime purpose of building, which is to provide comfort, and the energy is going in to provide this comfort. So, this is the operational phase of the building, and most of the emissions that are happening in this operational phase are going to come under scope 1 and 2. Where we are directly burning the fuel, for example, providing heating in extremely cold areas, the heating may be provided using a boiler or a direct radiator, and we may be burning fuel. So, it could be pellets, it could be gas, it could be other fuel, conventional fuel. So, direct burning of that for creating comfort inside or for other purposes, for example, cooking. So, this is scope 1. And the scope 2 would be where we are using electricity, energy which is produced off site, and we are purchasing that energy to create comfort or to operate the building here. So, most of the emissions that are going to come in the operational phase of building are going to come under scope 1 and 2. Now, this is the phase when the building is under use, but prior to this, when the building was getting constructed, so we have the emissions, we have a lot of emissions which are released during the construction phase, and that is going to be known as embodied carbon. So, not direct, but due to manufacturing of the materials, due to transportation of the material from extraction site to the manufacturing site, and then during the process of manufacturing, from manufacturing site to the construction site, the process of construction itself, all this will consume a lot of energy. A lot of emissions are going to be there due to the processes of manufacturing and also processes of construction. So, all this manufacturing, transportation and installation of construction materials and construction of buildings itself, there is a lot of energy that is going in and a lot of emissions are taking place. All these are sometimes upstream, sometimes when the demolition phase, the end of life phase of the building is there and we are demolishing it, there would also be some emissions that will be attached. All this is going to be scope 3, largely upstream and some of it going to be in the downstream, but overall this carbon, these emissions are going to be known as embodied carbon, and they are going to be part of scope 3. The overall emissions from this building life cycle, the entire value chain, are a sum total of this embodied carbon and operational carbon, just as we have the sum total of emissions scope 1 plus 2 and scope 3 as well. So, this is where all the emissions are going to take place from the building value chain, the entire life cycle of the building. If we look at certain examples, for in this case we are looking at District of Columbia. Buildings are the single largest contributor, which is 71% to the citywide greenhouse gas emissions. If we look at the world, which we have already seen, on an average they contribute to around 25% of the total emissions, and in certain places, in certain scenarios, we are seeing very high numbers. Overall, the fact is established that buildings plus transportation contribute to the largest amount of greenhouse gas emissions on planet Earth, and we need to look at both of these, and here we are focusing on building design and construction. If we look at real estate companies, scope 1 emissions will be the emissions that are generated by on-site combustion of fuels such as natural gas for heating or diesel or for backup generators. The emission in scope 2 will be due to the consumption of grid electricity, district heating or cooling, or on-site generated electricity from non-renewable sources, that is going to, if it is directly combusted on site, it is sometimes going in scope 1. And the scope 3 would be, which is associated with production and transportation of material, equipment that are going to be used in building construction and operation. And then the downstream one will be where we are talking about waste disposal, the transportation for tenancy purposes, for commuting, and also from lease assets. So, this is where all the emissions from real estate is coming from. If we look at the breakup of these emissions in scope 1, 2 and 3, we will see that the largest share of this emission in building value chain, building as a product value chain, is going to go in scope 3, where we are talking about largely the manufacturing and transportation plus construction of the building. So, most of the emissions are going to happen there, and secondly the scope 2 emissions. So, we have, this is because of the operations of the building, where we are purchasing the electricity, for operational needs. Now, if we look at this, this is the place where we can reduce, we can impact the emissions through selection of construction materials. So, selection of construction materials and also selection of construction process. So, we can select the technology appropriately, and materials plus construction technology will give us a reduction in GHG emissions under scope 3 of building life cycle, the value chain. When we are talking about scope 2, this is where if we make the building as an efficient building, it would be energy efficient, it would be water efficient. If we make an efficient building, we can reduce the scope 2 emissions significantly, because we will be reducing the amount of electricity required to run, to operate the building. So, these two are the scopes, these two are the tasks that we have to undertake to reduce the overall emissions of the building. And we also have a small percentage of scope 1 emissions, which are the direct combustion of fuel on site itself to provide comfort or for different processes, which is other than the regular process. For example, the manufacturing of some good, or for example cooking in case of messes. So, we are not talking about that, we are only talking about this direct combustion of fuel for maintaining a comfortable environment or for other building processes. Let us look at the case study of Mahindra Lifespaces Developer Limited, MLDL here, and understand how a real estate company is attempting to reduce the GHG emissions and what are the solutions and what are the scopes that they have identified for themselves. So, Mahindra real estate companies, multiple companies under the bigger brand of Mahindra real estate, they have committed to reduce the greenhouse gas emissions. They have set open targets for themselves, declared targets which are publicly declared targets, and they have been identified as they have committed themselves to set science based targets for reducing the emissions, and they are one of the champions in doing so. So, if we look at the overall numbers that the company reports, we will see that they have if you look at the absolute numbers from 2018 to 2021, we see that there is a continuous increase in the numbers, but these are absolute numbers which is also dependent upon the business. If the business grows, simultaneously the absolute numbers of emissions are also growing. But if we look at the emission intensity, so instead of looking at the absolute emission, if we look at the emission intensity, which is normalized based upon the total square feet or square meters of area of built space that is being delivered as building product. So, we see that the intensity of emissions is going down if we are talking about per square feet or per acre of the developed area, developed building. So, we see that they have been able to reduce it by almost 1/3 within span of 3 years, that these are the reported values. This is for residential buildings, and then if we look at the commercial and industrial buildings, again we see that the intensity is coming down, slightly lesser in commercial spaces as compared to residential, and the commercial spaces are also having a higher emission intensity. So, residences, as we can clearly understand, the emission intensity is significantly lower and it is higher in commercial spaces. If we look at the direct energy consumption, again we would see that the intensity of energy consumption is going down. So, we can see it here happening, almost half. The energy consumption intensity has been reduced to half, and that is where we see that the scope 1 and 2 emissions are significantly coming down. Now, what is to be done to achieve the target of reducing emissions which the company has set for itself? So, it has identified some of the specific solutions and tasks, steps to be followed. For example, there are the emphasis has to be on the type of materials which are going to be selected. So, this is scope 3, we are talking about the upstream. So, what materials to be used? The materials which have a higher recycled content. So, fresh extraction and manufacturing is not required, we will be saving GHG emissions from there. Then we are talking about the construction energy efficiency and energy audits. So, energy efficiency during construction phase, we are talking about passive architecture. So, how we can make the buildings passively comfortable, so that less and less of energy is required to maintain comfort, or metering. So, we have said it multiple times that anything that we measure is what we start to value, and what we value is what we measure. So, if we measure the consumption properly, if we measure different heads of energy, where the energy is going, we will be able to be more efficient in using them. So, measuring, smart metering, and besides these there is also the intent to reduce the energy through behavior, because buildings are consuming a lot of energy during operations and the users are operating. So, if we train the user, if we educate the user towards behavioral changes, how to use the building in order to be more and more energy efficient, has been recognized as one of the important solutions. So, this is also integral to designing these offices. They are talking about sustainable offices, they are talking about identification of initiatives for efficient lighting and cooling, the operation of effect of DG set. So, reducing the requirement of DG set and how we can optimize the operation of DG set within different facilities. Also adding sensors across offices. In residences, people have a sense of ownership, while in bigger offices, especially the large scale corporate offices, no individuals are responsible. So, one is we educate them for bringing about behavioral changes, and the other is to add sensors to automatically reduce the consumption of electricity. So, these are some of the steps and points that they have identified for designing and constructing the efficient buildings. But if we look at some specific projects and the specific tasks that they have implemented there, for example, in MLDL Tathawade Pune, they have added internal insulation on selected walls to reduce the heat ingress and thereby reducing the energy consumption. For example, the application of solar reflective index paint, so which reflects a lot of heat, excess heat, increasing the effective window to wall ratio. So, if we are talking about, now this is a climate specific one. In some cases we will be increasing the window to wall ratio, in some cases we will be reducing. So, we have to clearly see which are those cases where is a higher window to wall ratio required. Lowering the window SHGC. So, if we have a reduced solar heat gain coefficient for window, there will be an impact on the amount of heat ingress through the windows. So, optimizing all that, not absolutely reducing, but scientifically knowing where and how much reduction to be made in terms of selection of materials or in terms of selection of passive design strategy, that will bring about a significant change. And with this, with such strategies, they have been able to achieve significant energy savings. As per the audited report, they claim that around 30 to 35% of energy savings have been achieved. Other strategies that they have adopted are roof insulation, improvements on existing window design, and provisions for ventilation and exhaust, besides the ones that we have already talked. And the energy savings are significant by doing some such steps, by implementing some such strategies. Overall, if we see Mahindra Life Space Developer Limited, it has committed to reduce the absolute scope 1 and 2 GHG emissions by 63% by 2033 from a 2018 base year. So, every time we see a company declaring its targets, we will see that there is a base year that has been identified and a percentage which has been publicly committed as a target to reduce. We are talking about GHG emissions here, and against those targets, which are science based targets, how will these targets be achieved? So, a proper working out of how the reductions are going to take place, what are the steps, what are the strategies, they have been duly identified. If you go to this dashboard, which is sciencebasedtargets.org dashboard, you can see that there are some 5,000 plus companies which have declared their targets publicly, and they have set the targets for themselves based upon science. So, science based targets for reducing GHG emissions. You can see a lot of companies which are there. So, we have discussed only 5 sectors and 5 different types of companies here in this week to give you an idea of where the emissions are going to accrue for different types of companies and how they can reduce these, also looking specifically at the contribution of building design and construction. But if you go to this dashboard, you will be able to see a lot of different types of companies and how they have set targets for themselves and what are they doing to achieve those targets. With this, we will close this week 5 and lecture 5 of week 5. I hope you are able to clearly identify the scope 1, 2 and 3, and I have also been able to communicate the importance of building design and construction for any business at large. From week 6 onwards, for the next 2 weeks, we will be understanding how to really bring about the emission reduction through building design and construction. We have emphasized enough how building design and construction can result in GHG emission reduction, but we will now see specific strategies that need to be adopted to actually have the reduction in GHG emissions. Thank you very much for joining me today. See you in the next week, week 6 of this course. Bye-bye.